vision of this conference is to become a premier event in India that brings together the simulation practitioners from all over the world. The conference plans to achieve its vision by providing a platform for consistent, productive collaborations and knowledge transfer between the industry as well as academia.
And ISCI as a forum is going to basically serve as a platform for all the communication happen between India and abroad, between India's manufacturing and India's academia, within India's academia, within India's basically process industries, manufacturing industries. And with that very lofty goal, we hope this conference goes on every single year from this point on. And with that, I'd like to say, basically, once again, basically welcome to you all.
It's a great honor to come to your beautiful country and present the opening of the proceedings to such a distinguished educator of India's finest university. Thank you.
I'm really happy that the group has decided to reach out and to start this international conference on simulation. And I hope that they will continue to make this an event once a year or once in 2 years, so that it can be a forum where this community of simulators, community of practitioners as well as theoreticians can get together and look at what are the challenges in simulation.
We have basically 5 companies sponsoring this event very, very generously. Without them, this event would be much, I'm not going to say not possible, but much smaller in size. Right? So first, I have basically a special mention to basically Simulate Corporation, who are our basically platinum sponsors. They contributed very, very generously once again to this basically conference, and I hope they keep the contribution going over the next few years, and I hope we can show them enough ROI on that investment as well. Simulate basically develops markets and supports business simulation software that enhances the way the people make and communicate basically decisions. They have a booth out here in the booth area, so basically please do visit their booth. Our next sponsor is ANSYS. ANSYS brings clarity and insight to customers' most complex design challenges through fast, accurate, and reliable simulation. Again, all of our sponsors today, they do have booths in the vendor area, so please do visit them, ask your questions, and basically keep them busy. Extension is basically a powerful, basically leading-edge simulation tool. Using Extension, you can develop dynamic simulation models of real-life processes in a variety of fields. Then we have Flexer, which is a software company that creates and provides simulation modeling services. As a high-tech company, they are driven to create bold new advancements in simulation technology in terms of flexibility, ease of use, customization, and basically 3D graphics. PMI, basically Production Modeling India, is one of the fastest growing industrial engineering consultancies in India. Our dedication to industrial engineering service gives you the confidence to increase your production, productivity, and profits and move your business forward. So once again,
to do line balancing, workload balance for operators, central office will send us key punch cards with elements of work. We spend hours, if not days, shuffling all these cards into those big giant trays, send them up here. Engineering, body paint, and assembly, those would be the manufacturing folks who design the new systems for the new programs in the plants, and then the manufacturing plants themselves. And every situation, product A and product B, that means if there's a new product coming down the line, product A might be a truck, and it's going to be out next year, and so the people designing those systems have probably already bought.
Sustainability in our field. After that, I come back a little bit into the simulation field again. I'm not going to go into the economics too much, because that we have been talking about most of the time here. I think all the presentations. And when it comes to fields, other things, and interactions and dynamics, so we had many of different improvements that had to be done. And after the project, we think we did a really nice, good job. So we wrote a report, like 2 inches thick maybe, solutions for waste. something like this. So economic growth and environmental load is increasing together. That's not good, right? Because the more we increase the economy, the worse the environment will be. We want to go the other way around, like this. So that's what we try to do with the measures as well. This is one example.
The long run average cost is continuously differentiated. Now here is a lemma that says that, so why are we doing all this? The reason why we are doing all this is that under the extended dynamics, the algorithm SPSA is analogous to a similar algorithm in which the theta IM in SPSA, which was essentially points on the grid. So those points are replaced by these points, theta bar of IM, where theta bar IM are essentially points in the closed convex hull. Okay, so those are being obtained directly. I mean, as you update the algorithm, those are points that you obtain. You don't really project them back to the grid. But you use that transition dynamics. These are the transitions. Both of them, it allocates a higher budget. For samples that are clearly not good, it doesn't allocate anything. And it does it in this manner. So if the variance is high, it allocates a higher budget. If the difference between the current best and the current estimate, the square of that is small, then it allocates a higher budget as well, just to see whether this is the estimate that you have now turns out to be better than the estimate. And in fact, between SPSA and OCBA, SPSA turns out to be better. So what that suggests is that continuous optimization approaches can actually be powerful techniques in discrete parameter simulation optimization. Now let's look at the results for the low-level policy setting. Herein the parameter set has a size of 10 raised to 8. So
good morning, everyone. So the title goes simulation, the good, the bad, the ugly. And actually we are not really talking about bad sides of simulation or ugly sides of simulation. For example, this shows how the speeds are dropping down as the condition is building up. This one is done again at NIST using software called TSIS. Moving on, another one being done at NIST. So interestingly, some of these solutions are required because in one solution you cannot do everything you need it to do. So the microstratics simulation we just looked at.
It's a very great honour to be invited to talk at this first Indian simulation conference. I'm going to be telling everybody at Winterson next year how good the food is here. Much better than Winterson food. I'm hoping to see this conference happen very often in the future to be back here. What I essentially want to do is talk about how, we all know that simulation is great and it transforms processes, but actually it transforms the whole management process of the organisation as well. It's not just about making the actual production line run faster, it actually improves the way the actual, the management around the thing works. Actually going to help the client reach a solution. Small models are often the right way to go. And I want to just explain that with a bit of logic, a bit of a flow diagram.
So in our department, University of Arizona Department of System Engineering is the first system engineering department established in the world in 1961. And then an IIT program has been added actually 11 years later. So now actually the department has both actually programs. And recently published actually this work in the journal paper. And then the last actually topic that I'm going to talk is energy. Since I talk about the energy, I want to still spend actually 2 minutes on energy here. And the energy, the point here is we want to determine the best location for the solar panels around the University of Arizona campus. What we do here is we need to check the power quality. As you add more PV, actually the panels, then the power quality intermittency actually becomes a problem. So that what we do here is we check the voltage stability, and then in this case, as you see that there is over voltage, which is not good.
And it's ROI justified. Will the same trend be prevalent in India? Will the low labor cost both in the industry and service sectors impact growth of DES as a tool in assisting in decision making? Will it impact it positively or negatively? How will research findings coming out of Indian universities find their way into?
My name is Björn Johansson. I work as assistant professor, associate professor at Chalmers University of Technology in Sweden.
Panel. I'm Edward Williams of Michigan. I've been doing simulation for over 30 years. That's how I became old and gray and pale and wrinkled. For many years at Ford. Now I do consulting work at PMC, which is the affiliate of PMI.
I'm Rajesh Deshpande from Mahindra & Mahindra Tractor Division. I head the department Central Manufacturing Engineering, and have about 20 plus years of experience in various departments and various industries. And I'm really glad to be here.
Many of you know it, but formally this is in Hemachandra and Engineering Operations Research IIT Mumbai. And this is my 50th year here. Thank you.
Good afternoon. My name is Randy Combs, and I'd like to thank Carl. Retired from General Motors after a nice long 36 plus year career.
Good afternoon. I'm Vikram from Larvick Engineering. Thanks, Karthik. I've been in the simulation line for 18 years, and I've worked for around 7 years in the US before coming back to India to set up my own simulation consultancy. I think in the developed countries, because of the high cost of labor, that in turn drives higher levels of automation. On its own, it has made simulation quite a commodity. But in India, with lower levels of automation,
this is being again awareness problem. It has to start from the academic side and further in the industry side.
So you're saying the awareness is the main problem?
Awareness is the basic problem.
About 15 years ago, when I started using simulation, there were about 6% of Swedish companies using simulation at that time, discrete events. Only the big ones, like the car manufacturers, Volvo Car.
And propose building a model. And before I let them start building the model, they must show me a transcript of their conversation with the customer. What questions did you ask and what answers did you get?
educational system in India, the students who come out do not have very strong analytical abilities. It doesn't matter what tool you use, whether it's simulation or mathematical equations. And the emphasis is more on clearing the exam and getting good grades. So there has to be a strong culture of analytical capabilities that needs to be built into graduates as they come out of college and university, so that they know that which tool to use and the right questions to ask, which is exactly what Professor Williams was saying. And as that comes out, then automatically, not just simulation, but other types of, we have operations research, which is also at a low level of usage in India. A lot of other tools that will get practiced in industry.
It's good to have a good simulation created. It's good to have analytical abilities to know what is required, what model needs to be built up. When it comes to the commercialization or actual usage of it in the industry, the question here is, have I really captured the need and have I used the right model to deliver the need or the...
It's going to prepare its students for the industry. Because I personally feel I'm in awe of IIT students. Right? So when I walk into the industry and I see 3 IIT students sitting there, I'm like, okay, I should really know what I'm talking about. So that feeling does exist. So can you please?
I wanted to argue with Vikram just a little bit. He's absolutely right. If you've got a model of any significance, you got to get good data to get results. However, Mark Elder discussed it more eloquently than myself for sure. And that is, if you're working with somebody in a situation, a throughput tool is simply a matter of starting out with a process flow diagram